Rene Descartes was a famous philosopher. He was a mathematician. But Descartes' rule of signs will help us to break down how many positive or how many negative roots a function might have. I typed his name in Google and found this. His most famous saying is, "I think, therefore I am." I put this into the other video, but for some reason it did not record the portion, so I'll put it here in this video. So here is an example function. When we want to count the number of sign changes, we will look at each term and look at the sign of the term. If you'll notice, every single term in this function is positive. So this does not change sign at all. They're all positive. So as I go from left to right, it is positive and stays positive. It never changes from positive to negative. Since that number is 0, then the positive side of the axis, the x-axis, this function will not touch it at all. It touches it 0 times. To find out how many times it may or may not cross the negative side of the x-axis, we first want to take every term that has an odd exponent and switch its sign. So the third power, that's an odd. First power is also odd. So they're going to change. All right, so this one's even, so he stays the same as he already is. He was positive, he stays that way. This was odd, so he's positive, he'll turn into a negative. This one's even, so he stays the same. This is odd, so it goes to negative. And this one is positive. So now let's count the sign changes. It went from positive to negative. There's one sign change. Now it went from negative to positive. There's two sign changes. And here again, 3. And here again, 4. All right, so this means it's going to cross on the negative side 4 times or less by 2's. All right, so what I mean by that is it's either going to cross 4 times or 2 times or no times. Okay, so this is what a 4th degree would look like. It would be up on both sides. So we know it's not going to cross over here at all, but it crosses over here up to 4 times. So that would be 4 times, or maybe just 2 times, or not at all. So that's what we mean by 4, 2, or 0. So here's another example. So it is negative, then it goes to positive, back to negative, and positive. So I have from here to here, that's one sign change. Here to here, that's a second sign change. Here to here, a third sign change. All right, so when you check the function as it is from the beginning, then you're checking how many times it crosses the positive side. So here, it's either 3 or less than that by 2's. So take away 2, we get to 1. Now, since 1 minus 2 would give a negative number, and I can't cross something a negative number of times, then I stop at 1. This means I'm guaranteed it will touch at least once on the positive side. Let's check the negatives now. So I change every odd exponent. So the 3 is odd, it is negative, so it's going to switch to a positive. The x squared is a even number, so it stays positive. And then the 8x, that's an odd because the power is a 1. So it's going to switch. It's negative right now, so it should be a positive. And then the 1 stays the same. So I'll count the number of changes. There's no changes, no changes, no changes. So on the negative side, it will not touch at all. So a 3rd degree function would look something like this. And we discovered it does not hit over here at all. It only hits on this side. So it hits 1 time or 3 times. And that's it. So from the rational root theorem, we know this function has possible rational roots at these places. So there's 6 numbers there, but it's plus or minus, so really it's 12. So if I use Descartes' sign theorem here, I can count the number of positives and negatives, and if there are no positives or no negatives, then I can cut this 12 possibilities down to only 6. So real quickly, you can see they're all positive, no negatives, therefore there are no sign changes at all. So I can take these positives and just say those aren't it. That's gone. 6 eliminated just like that. Then I count the negatives. So all the odd exponents change sign. And now I've got from here to here, that's one sign change. From here to here, that's a second sign change. And from here to here, third. So it's going to hit 3 times or 1 time on the negative side. So I'll just check those negatives and go from there.